Wiley.
Okay. Yeah, so the area that I'll be talking and focusing in is highlighted in red, and those are the kind of the least areas that we're currently monitoring under our framework that we're doing. Huge project team. It takes a lot of people to do this. I wish I had about 8 more because it's pretty complicated. But here's some of our staff up top, Mama staff up top, and then some of our partners, Jeff Nebo and Mike Frisk and Ollie Shipley from Stony Brook University. And a lot of this wouldn't be possible without Kevin Work, our commercial fishing partner that really helps bridge the science and communities together. Simple question, why telemetry? This is a telemetry workshop, so we know the reasons behind this, but most importantly for developers, we look at this as a non-extractive approach for monitoring, which means we're not removing the organisms from the environment. A lot of the surveys that currently still go on are still benthic trawl surveys, scallop surveys, surveys that are removing organisms from the ecosystem. When you kind of scope this out for 6 to 8 years or longer, it starts to be a lot of biomass that we're trying to handle and organize. Telemetry is not extractive, works awesome. And as we know, telemetry is great because some of these tags can last almost the whole time frame of a project. On some of the species I study, sturgeon and shark, those tags are 10 years. So we tag them once, then we can kind of look at them throughout. And tags come in all sorts of sizes, shapes, sensors now, which makes really collecting data really, really good. And then obviously data sharing, right? If we can get data sharing like Jeff, but offshore wind and renewable energies being explored everywhere along the coast, from the Gulf of Maine to the Gulf of Mexico. So the connectivity in using acoustic telemetry as a tool can be really powerful when we're looking at effects on whole populations along the coast, which many of the species I study do. As Dave mentioned, migration, fish migrate, right? The mid-Atlantic's a hugely important area for anadromous species and other species like sharks and tuna. We have this huge north-south migration every year, as well as many species have an offshore migration, like fluke or summer flounder and some sea basses and stuff. They move onshore, offshore. So this is a hugely dynamic area with lots of stuff going on. And then you sprinkle some other things like the cold pool and climate change. And we have a very dynamic system to kind of study. Question simple. We had a whole workshop yesterday. I'm glad we did that. Question simple. What are the effects of offshore wind on species? Particularly our contracts that we're looking at. We want to know the distribution, connectivity, and behavior of the fishes pre, during, and post construction. We have a billion other academic questions that we can answer, but that's not what we're being paid to answer right now by some of these projects. We'll explore lots of that stuff. The projects that we're currently conducting, one of the big ones right here is the New Jersey DEP Resource Monitoring Initiative. This is money collected by the state through the purchase power agreements. So they've agreed on a dollar amount ahead of time. I think it's like $10,000 per megawatt. It goes into a communal pool, and then the state decides on how to best use those funds to resource monitoring. This other project that we're doing is from Equinor or Inspire, looking at that wind development too. Really fortunate in that BOEM funded a similar project up in that exact area. So we have a lot of pre-data here. This is being funded right now during this pre-construction phase, 2-year contracts, as we were talking about yesterday. But we're hoping for that next batch, which we are in discussions with now. But we all know acoustic telemetry takes a lot of time, right? By the time I even put the stuff in the water, contracts up. So we got to kind of continue this stuff. Strategy. We talked a lot about strategy and development yesterday. It's complicated, particularly in New Jersey. We have, at least from our state surveys, 214 different finfish species that we can tag or look at. $1 billion commercial recreational fishery, and then sprinkle in the species of ecological significance like Atlantic sturgeon or some of the prohibited sharks. So we have to pick something and do something to analyze. So we took the shotgun approach. Let's just tag everything that we can get our hands on. A little bit at first, a little bit of each organism. We're looking at like 30 to 50 per fish or per species over 2 years for both projects. So it starts to snowball out to 100 per species. We'll take our 2 years and figure out what species are working best before we engage in our next round of stuff. But we're using all sorts of tags, all sorts of transmitters. I can tell by looking at your faces, this is messy. When we look at detection range and detectability, we'll get there through some range testings. We talked about mooring design. We use the acoustic release, a Nova Sea acoustic release, and we use this with a recoverable mooring system for a number of reasons. But I will point out problem number one, they're big, bulky, and heavy. I calculated out, so like it's a 100-pound anchor, and then the units themselves, so it's about 140 pounds total, which I'll explore again in something else. We also equip many of the units with other sensors. We're interested in turbidity eventually, right? We thought the turbines might produce some sediment plumes, DO, salinity, and all sorts of other sensors that we're trying to kind of also shotgun throughout our arrays so we can get some good baseline information. Why do we use acoustic release with a mooring recovery? We have a whale problem in the mid-Atlantic. Not that whales are good. We have lots of whales, as I see Rob over there. But along the New Jersey coast, several of them have washed up deceased for a number of reasons. We don't want to entangle a whale, so we went with this ropeless recovery instead of vertical lines to make it a little bit easier on us. And then commercial fishery interactions. In our early projects that we did for Orsted South Fork up in New York, we did have some gear interactions. We used to use like a 300-pound concrete block, which was a no-go when a couple fishermen trawled them up. So we switched this. We tried to make the package as small as we can, make it manageable for them if they happen to haul it up on deck. But as I mentioned, they're big. Takes 2 people to deploy, unless you want to bang that unit around and do it. And you need kind of bigger boats to do this, at least when we want to do everything all at once. We need bigger boats. Our deployments are a little over 130 based on all the projects. We have 54 up in our Empire Wind site, and that covers the offshore lease area and the cable landings. And then for our RMI project, because that's a New Jersey DEP funded project, we encompass all the offshore wind areas for a total of 82 receivers to cover multiple cable landings, multiple lease sites. You'll see there's a lot more receivers inshore because those sites were supposed to be developed a little bit faster or were a little bit higher in the time frame. Whereas our offshore lease sites, we're just kind of doing some exploratory stuff to try to get them baseline. But those sites, could be 5 years out or longer. So we'll get good baseline data when we look at it. But for our RMI project, we kind of broke it up into the lease sites and then what we call gates and gradients, trying to do our best to understand changes and potential changes. So in our gates, we bracketed the potential cable landings. They're about 3 kilometers apart. So we should be able to get good movement data on fish moving through those areas before they're electrified or potentially electrified. And then we took kind of a gradient approach on our inshore lease areas that were fully developed to look at kind of an inshore control, a lease area, and then an offshore control to see if we can kind of detect any potential changes once these systems come into play. We're trying to reduce problems everywhere we look. One of the ways we do this is cooperative research. We can go out and tag all the fish we want as scientists through our surveys, but I try to engage as many recreational commercial fishermen as we can to get them involved in the process. And this is like really helped a lot of the stuff that we do. This group, the Berkeley Striper Club, even made a nice little sign for us as we go up and down the beach, because they didn't want people stopping or thinking about, like joining our group or whatever. So they were like, we wanted to tag 50 stripers and they wanted to be the ones to do it. So it was a good group. The guy on top too is Nick Honishevsky. He runs his own fishing show and channel on Discovery and Disney, and that's Saltwater Underground. So they do lots of things. Lots of fish tags. We're in the midst of it. We've got sturgeon tag, sea bass, tautog, striped bass, cod, not to mention all the other stuff we're doing, right? Like this is from our previous studies, lots of sharks and lots of different things. We talk about cooperative research, data sharing. This is not from this project, but one of my receivers off New Jersey that I had a couple of years ago. I think 5 of these tags were mine. So lots of different things, and this shows the importance. The Mid-Atlantic area, this is going to be a huge migratory route. I'm going to detect all of Bill Hoffman's striped bass, like many of us do. But this is, Jeff mentioned how things get moved around. This is a receiver that Atlantic Shores had, and you can see the green dots. They did move it around a bunch of times, but it shows you how many things will be detected. I mean, this is all sharks and rays and stuff before we even put tags out for this project. So we're going to see lots and lots of data. Up next, we're kind of doing lots and lots of different things, but I thought I'd share some of the challenges and lessons we've learned along the way. One thing, we put receivers out. Offshore wind is in windy places, believe it or not. And 5 days later, we get the biggest storm surge on the New Jersey coast we've ever seen, 20-something foot waves. And that unfortunately moved or washed up whole units on the shore. So you wouldn't think about the energy it takes to move 150 pounds, 20 feet offshore. So we got to think about that a little bit more, mooring systems. The need for regional data sharing and coordination. This is the constant theme that we're talking about. But we have to coordinate. These are migrating species. These species are moving. We need to look at regional impacts as these fish move through probably almost every wind area site along the East Coast. I put this up. That's some of Jeff's receivers that we just saw, but some of also Stony Brook University's receivers that we have, and the NJDEP receivers that we have, and Rutgers University. When we look at the Mid-Atlantic as a whole, we have a lot of receivers listening, but we don't all coordinate and communicate with each other because we have limitations on the funding agencies on how we can do that. Health and safety. You don't think this is a conflict or a problem, the last thing on your minds, but we have a brand new boat sitting there waiting for us to use. We can't use it because our lifeboat that we ordered in March didn't come, and the companies don't want us going out without our SOLAS approved life raft when we have a U.S. Coast Guard approved life raft. We got flagged one time because our vessel refrigerator didn't have a logging temperature in it, and they were like, you could drink spoiled milk or something, I guess they could say. But health and safety is a constant theme about what we do, and we have to, like, it's a whole nother level of life preservers and safety equipment that we have that is an significantly added cost, as well as a lot of time to maintain and record those things. Infrastructure. We're used to working in coastal systems, but we're going to need a bigger boat. So we use commercial boats, and for Monmouth University, we had to we bought a whole new boat just to support ourselves because we were renting so many other university and other contractors' boats. So you don't think you need a big boat, but you do, and I'd go much bigger, add 15 feet, if more. Spatial planning conflicts. We put some gear out 1 week later, as trawled up by a commercial clamor. So communicating those conflicts, not just with us, but other scientific surveys. So we have researchers doing clam surveys and benthic trawls, so we have to communicate that. Data sharing pre and post. We try to share all our latitudes and longitudes for our receivers with as many people that we can. And then regional approach. I work with Jeff a lot. I work with Sternberg a lot. We try to uniform our designs and systems as best as we can so that we can make these big comparisons. And that's it. That's my timeline of stuff that we're doing, if you have any questions.
We have time for a question while we change these slides over.
I think both you and Jeff, if I understand what you're saying, that tags that you put out under a contract, you're not putting into the database.
Correct.
So others are detecting your tags potentially, but you won't know about. And the opposite is true as well. You could be detecting other collaborators' tags, but you're not allowed to tell them without developer permission.
Yes.
Yeah, for some companies.
So that's the brilliant with the RMI program. It's run by the state. Share and do as much as we want with all the data. They're happy, but they're working with it. It's absolutely amazing. But with working with the developers, we have a little more restrictions to get a little bit more complicated.
So if developer programs expand, there's a potential that ag reporting is actually going to potentially decrease if more and more people can't tell each other that they've detected other tags.
Work on it. That's where organizations like Rhodes and others at Steve hopefully makes us changes.
Yeah, so yeah, great clarifying questions to make sure that we all understand some of the issues at hand. So our last speaker in this session is Mike O'Brien from University of Maryland Center of Environmental Science.
Hello, everyone. So I think rather than talk specifically about an active project that's going on, I kind of wanted to give a little bit of a retrospective of what we were doing in our area that allowed you to possibly get some of the tag detections they had before, or hear some of our other fish, and the process of building it through, driven specifically by offshore wind development in Maryland, and how it's kind of changed our approach in what we look at, not just in terms of mooring designs, array designs, anything like that, but even in the species and the family genera, like large animals that we're looking at holistically in what we're seeing. And mostly this has kind of led to our shop working specifically Dave Secor and Helen Bailey, taking just a general movement approach. Helen background is in dolphin and porpoise movement, and that kind of went more largely into whales. Dave, obviously fish. So how do we rectify these systems and bring them together and work as one kind of shop? So the US wind areas, you saw it a little bit in Keith's map. It was the little tiny one. I feel I have like a problem with scale now. I saw how big Jeff's areas are and how big I feel like we're running a podunk operation now. There's this little blip. Yeah. So there's basically 3 development phases going to happen there, starting farther offshore with what they call the Marwin energy area. It's going to be 300 megawatts, which has 21 turbines and 1 offshore station, and then move to what they call the Momentum wind area, Momentum project area, and move from there. Originally, the idea was for the Marwin energy area to start construction in December 2025. Looks unlikely due to supply chain issues and things like that, contracting issues. And then the Momentum starting in 2027. This is a handy, I think, really good diagram provided by Boehm in terms of what the process is kind of from cradle to grave in these areas. For us, This leasing process occurred April 2010 through June 2013. There was a bidding process on August 19th, 2014. That bid was awarded to US Wind at the end of 2014. We're now a couple of years forward on this process, and the construction operations plan and draft environmental impact statement, which were released both in autumn last year. And in the middle, we kind of had a smattering of research of various points. And I just wanted to kind of give kind of an outline of this. So we first had this MARMAM project that we called, which is specifically looking at locating whales in this area, and a little bit of looking at dolphin and porpoise presence. And this was a project led and run by Helen Bailey. And they had a large array of instruments out there. And big ones I kind of want to point out are the stars, because we glommed on to what she was doing and said, hey, can we throw like a VR2W on some of those things? I was like, yeah, sure, why not? It's not going to cost too much. So just using a ship of opportunity, shoestring along, no real budget, we were able to put some of our fish receivers on what was a specific purpose-built kind of whale, dolphin, porpoise array. From there, they were originally going to put out some meteorological tower. We wanted to look at impacts of that. So we now were able to kind of put out our own fish arrays, just these 3 little tiny spots looking at what pile driving impacts might be. This never happened. So we had a lot of baseline data of, we talk about how arrays get to be where they are. We have a lot of baseline data for something that will never be an impact, because this thing was not built and never will be. So it's kind of interesting how that kind of develops. Then we moved into a BOEM funded project from Dave. It's called it Windfish at that point. And that was looking at movement through this area and leveraging the lessons learned from Helen, which we kind of overlapped, see in the timeline there, of making sure that we had this gradient design. We had kind of inshore receivers looking at fish, and these overlap with some other inshore receivers looking at whales, porpoises, dolphins. We had array designated receivers. We had offshore designated receivers, because in this area, Keith had mentioned cold pool. It's really funny down when we get to this area of Maryland, because our water is really pinned up against the shore, the Gulf Stream, and Cape Hatteras. So we get really, really hot on the top and really, really cold on the bottom. And then that completely flips in the winter. So we have a very strange temperature gradient offshore that doesn't exist as strongly elsewhere on the coast. So we get to get that as well as depth. Then we had, I think you guys, some may have heard me talking about it. We had a random DARPA funded project where we threw fake robots at black sea bass. And that was out there for about a month in 2019 using some of those stuff. But again, we were able to kind of co-locate some of our instruments there. And we've moved on now to this project that we call Tailwinds. And I encourage you to kind of visit our website if you want really more in-depth information on that, or if you want to kind of access the reports that I linked up there. It's tailwinds.umcs.edu. And going through this point where we were dancing around each other in the 2 lab groups saying, okay, well, this is where this data is, and this is here, and okay, this is the funding sources. Dave and Helen worked together to bring that all under one house, basically funded by US Wind, and saying, here is everything, here's the patchwork quilt that we have. It's going to work a lot better if we bring all of this together into a singular program. And you kind of see that here, where we have a history of pretty solid co-located passive acoustic monitoring equipment, as well as acoustic telemetry. And these 2 types of equipment are interesting in the fact that they answer similar questions in completely different ways that aren't actually completely different. They're almost the same, right? They're using acoustic waveforms to try to identify the movement or migration of different animals, but fish don't make those noises. So we synthetically create that. Whales and dolphins do move that. It's just kind of neat. So we really sought to bake in the relationship between the passive acoustic monitoring and the acoustic telemetry using our lessons learned. So we talked, I think that all of us have hit on this morning. We talked about ideal array designed. And what's like the one apocryphal thing is like a camel's a horse made by committee. Here's our array. Our array is this beautiful idealized thing created by patchwork funding sources. So this is all of what we had up there on one map. That's not what's out there now. It's been pared down for purpose, but I just want to kind of put that all up there. It's a bit of a monstrosity. And I just wanted to emphasize that the one thing that it did hold true through this, which is nice, is this gradient design where we can kind of say, okay, what are, whoops, sorry, I keep tapping the thing. What are the differences across space? So that's kind of our framework, speaking to the point where it's like, okay, how do we rectify these things? How do we justify things? How do we use lessons learned from a passive acoustic monitoring project and an acoustic telemetry monitoring project and put them in the same house? What are the benefits out of this? One is, we've seen this from some of Keith's gear and others, and I'm sure that a lot of us do it, is co-locating instruments. So we have multiple instruments recording different things at different times. So we have a different array, and ironically, because we're studying marine mammals and their instruments so big, this is the mooring that puts the most line in the water, which we're trying to adjust. But we can strap basically receivers on top of each other so that we have things recording the same thing in the same space at the same time. So these F-pod click detectors are specifically looking for dolphin porpoises. The LS1X that you have outlined here are a little bit more broadband. They can pick up whales and anything really making noise out there at some time. So we have co-located data, which is pretty nice. We can move into joint phenology of what type of animals are moving through here at different points. And you see that this started off a little bit in our little PAM or acoustic telemetry silos. On the left, we have what we're able to pick up using PAM, passive acoustic monitoring. On the right, we have acoustic telemetry. This is an ongoing venture that you can follow on our website as we get through. And it's actually a point now where we're trying to rectify these and put it into kind of a broad, a joint phenology figure so we can get an idea, not just fish, but mammals. What does that look like? When we went off and tried to shock black sea bass with a fake underwater vessel, we were able to look and say, okay, well, we also have these co-located gears. We're looking to see if there are dolphin impacts. Are dolphins impacting black sea bass movement? In this instance, no, but vessels were. So it's a little bit of a null result, is that, black sea bass kind of have a little bit of a diel vertical migration. They hide in the reefs during night, and in day they kind of go up and down. Not really affected by the presence of dolphins, affected by the presence of vessel noise. It's nice to know that, even though it's a null result. A lot of this work went directly into the environmental impact statements and even construction operations plans. So just having that background built in, not directly funded by the agency, most of that work was done by BOEM, went directly into what the plan of construction is going to be and how these are going to be built out. There are challenges. We have an industry cycle. The industry giveth and the industry taketh away. So we have, a little bit of constriction, say, okay, this isn't what we're going to do. Well, it allowed for repositioning. Otherwise, repositioning in terms of what wind credits different developers can use dictates how fast they can build out, where they can build out, when they can build out. And sometimes they need to reprioritize those resources possibly away from research that they can build quicker or do other things. And you see this a little bit in this dark ages. This was not affected by the funding. So this is by kind of our own imposed funding cycle. We didn't get out there. But I think what I want to drive home here is that despite your best efforts, a lot of this is ephemeral. Keith works on 2-year schedules. Other people are trying to piece together type of stuff. I think relying on consistent data, it can sometimes be very, very risky, despite our best attempts. Whoop, oh, didn't mean for that to animate. We talked a little bit about technological advancement. We always think this is going to be a great thing, but there are actually sometimes challenges associated with this. Touched on Jeff a little bit in our discussion yesterday. Is can we just slot in new instruments? And this is something that we're on the PAM end working with Caroline Tribble, is trying to compare their C pods and F pods, and basically they have internal click detectors and feeding detectors of dolphins and porpoises feeding. They have this new and improved F pod that has a great algorithm, a better detection distance, better logging, and all of a sudden we have, during comparable periods, much higher detection of these animals than we did before. And then it raises questions saying, well, is this just instruments? Do we just all of a sudden have more dolphins or porpoises in this area? And this is something looking ahead that I think that we as a telemetry community are going to have to struggle with as well. If we get new kit that all of a sudden has vastly larger detection distances, we're going to have to judge whether increases in detection, whether increases in presence are due to the receivers themselves in these new technologies, or if they're due to the changes in ecology. Data structures, this is something that Dave and I just went over. While it's nice that we're kind of looking at logging presence of animals due to sound, they're at different scales. If you have passive acoustic monitoring out there, anything that's making a noise gets logged. So really, you're kind of able to sample that entire group of animals moving past your instruments because they're making noise. On the other hand, you get the individual level with our fish, and those are two different scales of data. With our fish, we have to make inferences back to the larger group of animals that are moving through there. Are what we detecting, is what we're detecting representative of the larger, movement of animals through there or not? And it's kind of flipped where we don't actually have any information on the individual marine mammal, though we have a pretty good idea of the group moving through. And rectifying those and moving into joint frameworks, I think, is an exciting challenge. It's a positive challenge, a challenge that we want to get after because there is a solution here. We just need to figure out what it is. And moving forward a little bit to the future, so this is the old map, not the new map done by Kim, but the map created by many of the people in this room, kind of showing what the telemetry array was at that time. This is a map from showing all of the PAM, the passive acoustic monitoring locations there. And if you see, obviously, because we all don't want to venture too far from the coast and we have population centers, they broadly overlap in where they're deployed. And this is a very good opportunity to start melding some of these data sets together and seeing what kind of joint modeling frameworks, decision-making structures we can do, not just in our silos of fish versus mammals, but kind of bringing them all together. And looking at those in a joint movement framework up and down the coast through these lease areas, not just looking in what might be considered, an Eulerian perspective, where we're sitting there, we're watching the flow of animals go past, just keeping our eyes shut, not necessarily, and hopefully moving to something that we could think of more physics, more of a Lagrangian aspect, where we're taking a pool of fish and mammals and following them as they move up and down the coast and seeing what they're interacting with in that time frame. And I think actually that's more or less where we are. That's kind of our prospectus of trying to build out these surveys.
There's a question in the chat that I'll pose to Mike, but all three of these speakers, which is sort of what's the what do you think might be the timeline for data from these projects flowing into the Matos framework and sort of for each of your different projects, because I know that varies across the projects.
So I'll start because we're easy. I don't know who we hoodwinked, but it's in there, and everything that we get is pretty much in there as we go. So, who'd you hoodwink, Dave?
No. Developers are very progressive. Yes. They have no problem every time they say share the data. And part of that, I think, is the real-time whale code, because you have to share data. On that. That's the way it works.
Yeah, so to give a little bit of background, in terms of this, I didn't necessarily talk about just because they weren't co-locating moorings, as we have a real-time whale code. And there's a couple that are up and down the coast where whale goes by, makes a noise, there's an onboard detector that logs that, and it's sent to through the ether to our analysts on shore, and they go and say, yes, it's a dolphin, no, it's not a dolphin. Or sorry, not dolphins, whales. So dolphins are kind of what we're looking at. So whales, and specifically right whales, but also other endangered whales, so they can kind of go through and say, yes, it's here. And that is live, that is updated constantly, that is always there. So it's a little bit of a wowie factor where it's like, oh, it's so neat that this is the utility of getting this type of information and sharing it, is I can log on and see this immediately. I can handle a phone call from a concerned citizen and say, actually, we're on it right now. 15 minutes ago, there was a whale present here and not. That's another, I think, moving towards that. So seeing the value of our developers going through there and saying, oh, I can see just in this small point of having immediate data sharing, the value that it lends to me and offsetting concerns elsewise, we can translate that pretty quickly into fish. So I think that you could even see in our array up there, kind of marine mammal dominated, and we were slotting fish in there. And I think having that be a little bit of the driving force allowed the ease of that kind of progressive view of data sharing that US wind developers have. Correct me if I'm wrong.
The only thing is the PAM array, that data is not being shared. So that data is more kind of, we need to get permission to share.
You need permission to share data, but also I think the forum for that isn't fully built out yet in terms of that network.
And ACT is really built into our.
Correct. But it's a different answer to those things.
Yeah, they just, yeah, do you two want to sort of speculate based on the timeline to get where you are, like?
For me,
Yeah.
yeah, for me, the big portion of our project will be up, it's just we haven't downloaded anything yet.
Right.
If the project's going to do the online, so we're able to share that with some of my other projects. You know, hopefully soon.
I'll follow up with that. So as I said, one developer's data are up, the data from the Mass CEC, Mass Clean Energy Center pilot projects have been up for years in Matos. And it's the rest of the developers is, I think, 3 or 4 other companies that it's need to work with to get over the finish line. I always talk to them about it, and hopefully when more people do, we'll head that direction. So I don't know, maybe this year, maybe next year.
Yeah, great. Well, thanks so